Hello, everybody, and welcome to Hash Rate. My guest today is Robert Myers of Hone, Hone, Subnet 5. Hello, Robert. How you doing? I've gotten a lot smarter about AI, but I come naturally sort of out of the pre-AI technology and crypto space. So I've learned a lot about what is training, what is pre-training, what is training, what are things like gradients, which help sort of focus the AI in a specific direction. And what I've read up on Hone is you guys are attacking we want to head towards AGI problem. So why don't you tell us in your own words what Hone is and how you are attacking the problem?
Yeah, so first, thank you again for having me. It's great to be able to explain these sorts of concepts and what we're working on with the subnet. Hone is a subnet 5 on Bittensor. What we're working on is we're trying to allow for novel mechanisms for solving a solid benchmark like Arc AGI. If you don't know what Arc AGI is, it's a benchmark that's created by the Arc Foundation, and it has a prize as well. It's $750,000, a very large prize. Francis Cholet is, I believe, one of the guys that works on it. And so, what we're trying to do with Hone.
So it's sort of like, let me just stop you there for a second. So the original idea, this test,
yeah.
the Arc AGI test, it's sort of like the SWE test is for ridges, right? Like, so that measures the software engineering benchmark test that measures how good of a software engineer the AI is. This Arc AGI thing measures how well a job you've done in creating artificial general intelligence, which by the way seems to have like a lot of different meanings depending on who you talk to. But in general, from what I understand, if you look at something like an LLM, you look at artificial intelligence like Grok or ChatGPT, it's very excellent at finding new connections between things in its training data that no human has noticed before. So it would seem to be sort of generalizing, but it's not really generalizing. It's just connecting new dots in a matrix of factoids that it has in its data corpus. But it's not very good at sort of generalizing it the way a human would to make intuitive leaps to truly solve new problems in a novel way, right? Like something like Francis and Crick realizing that the DNA double helix is the formation of, that's the structure of the molecule. So some leaps like that, artificial intelligence that isn't yet very good at. Did I describe that accurately?
Yeah. So one of the main issues that we face with LLMs right now, which is the predominant technology that has been widely adopted, ChatGPT, Claude, these technologies most of your listeners have probably interacted with and used before. These are all transformer-based models. And essentially you can think of it as like a Gaussian distribution or like a normal curve. From if you've taken high school statistics, you've probably seen the normal curve before. All of the data that exists outside of that distribution, it's going to have a really hard time generalizing to that information if it hasn't seen it before. And so this is why the data sharing and the data collection is so important for those companies, because every new piece of novel information that they're able to subsume into their next pre-training run makes their models more performant. But a human doesn't need to see a billion examples of how to drive a car or how to slice an apple, right? We can see it once or twice, and then not only can we slice an apple, but now we can slice a pear, and
that's
we can
a great
slice,
way to describe it, right? Because we're like,
right?
Oh, it's kind of like this other thing that I've seen before. Like that little leap is like really hard for AI to make right now.
Exactly, and it's inherent to the architecture of transformers. And so what we wanted to work on with Hone, and something I've been working on since my time at the foundation, the Open Tensor Foundation, was Yan LeCun's JEPA idea. Yan LeCun is the chief scientist at Meta. He was also one of the creators of AlexNet. which was in convolutional neural networks, which was kind of the beginning of the first AI boom in 2010. There were a few handwritten digits, called the MNIST data set. And they would teach these convolutional neural networks to recognize handwritten digits. And at the time, it was really incredible. By the way, the reason why NVIDIA GPUs are predominantly used in AI training nowadays is because that team used NVIDIA GPUs in the creation of AlexNet. And so there's a lot of history in terms of where we've come from and where we are today in terms of that. And so what JEPA is really all about is JEPA stands for Joint Embedding Predictive Architectures. So instead of it being there's what transformer models like ChatGPT do is they predict the next character. And I actually think that is a really great pre-training objective because I'm forgetting his name right now, but in a conversation with Jensen, he was describing it like a detective novel where you read this entire book and the last word of the book is who did it, who committed the crime. And so all of the words that came before are really important to that last word in the book. And so it's a great pre-training objective for solving those types of problems. But like I said, if the answer was someone else entirely that was not a part of that book, there's no way that the LLM will ever be able to answer that correctly. And so with JEPA, it does a sort of different type of pre-training objective that was very popular before ChatGPT, called mass language modeling. Or at least this is for the AI folks out there that are familiar with BERT and these sorts of technologies. It's kind of like fill in the blank. So, like when you would take a test when you were a student, they would remove a word in the middle of a sentence and then you would have to do A, B, C, D and fill in the blank, right? So mass language modeling works a lot like that. And JEPA kind of takes the same way where it learns, the JEPA model learns what's kind of supposed to go in between there. So it allows for like what I'm saying where, like you've sliced the pear. It intuitively understands what it means to slice an apple and how to slice a pear. So it can translate that
so by basically leaving a blank in the middle, so LLMs work by predicting the next word, almost like an autocomplete, right? Like it's sort of done this, I call it it's inhaled sentience exhaust, right? So if you look at the entire corpus of the internet that we've produced over the last 30 years or whatever, that is the training data and other things for LLMs. But that is the exhaust that sentient minds have produced, right? So the AI doesn't really know what's in there. It just knows when it's observing the sentience exhaust, what words are most likely to follow the previous words, based on statistics. It's just a big statistical matrix multiplier, effectively, right? So, but it doesn't really understand anything, which is why if you leave the training data in any way, all of a sudden you're through the looking glass as far as the LLMs are concerned. It has no idea what you're talking about because the sentience exhaust doesn't contain the answer, right? So it's very sort of brittle in that sense, right? Whereas you're saying that this other method where there's like sort of a hole in the middle, that's better at sort of generalizing, even though it's using language, it's better at sort of artificially, I guess, popping outside of the sentience exhaust in new and novel things. Is that correct?
So the one caveat there is that it's multimodal. So meaning that you could put in on your X or one of your inputs, it could be, so the joint there is like image and text, or it's like image and depth perception data. So like I could use like a self-driving car as a really great example of this, where if you think about what's happening in a self-driving car and in a robotics sort of problem, it's doing sensor fusion. So it's taking in all these different types of inputs, whether that's LiDAR data, that's camera data. Multiple cameras are using that for perception data so they can understand like how far away something is, like depth perception. And then fusing all of that together in order to make a decision or an actionable output, right? So what a JEPA would do is you would have one input, you would have two modalities that, or two or more modalities that you would input there. And so that actually allows for you to have sort of different perspectives. Like if you were making like a Burger King ad, you know, you don't want just one shot of the burger, right? You want to have maybe like a horizontal shot, then you want to have like the isomorphic shot, and then maybe you want to have like a zoom in shot, right? So then you can get a more complete picture of what you're looking at. And so that's sort of the idea behind JEPA. And then from there, and Jan LeCun talks about it. And I would like to add, for those who are familiar with this 2022 paper, right? It's a little bit hand wavy, but it's a sort of conceptual guide on what Jan LeCun thinks. These sort of animalistic type, how to make a computer think like a human, think like an animal, because like if you look at a lot of industrial manufacturing, right, they don't really look like our hands. It's a tool that's specific to do a very, to produce a very specific output, like the gigapress at Tesla's factory. It prints, you wouldn't have that for doing something else. It only just stamps out these pieces of metal, right? And so LLMs are a lot more like that in terms of its architecture rather than how we think about things. And so JEPA is a lot more of inspired by us and by animals in general.
Okay, so you basically created Subnet 5 Hone, and it's an attempt to make an AGI computer, right? So artificial general intelligence. And it's a big moonshot. Like nobody's succeeded at this. Like Elon has not succeeded at this. Nobody's even close, right? As far as from what I've been reading, everybody's scoring like around 5% right now on that test. So everybody's getting like an F minus at the moment, right? So how
and to be specific, what the Arc AGI benchmark tests is very, very much the whole point of it is so it's supposed to be easy for us to like solve, but very hard for AI to solve. And so like a CAPTCHA. And so there's a few global rules that once you learn the global rules, you can apply it and solve it very quickly. And so the idea is that a human can solve it within a minute or two, and then be able to apply those rules to all of the examples in the test. But still, AI, the very large language models that are out there today have not scored anywhere near.
So it's a generalization test. Can you figure out that if you slice an apple, that a pear is like, oh, it's basically the same thing. I slice it the same way, and it's okay. Got it. Very interesting. Okay, so basically, Hone is intent on trying to crack this. And you want to use a subnet to do it. So it's sort of similar to Templar in some ways, right? Like Templar, but it's not similar because Templar is basically, they're pre-training. So it's decentralized Colossus. So Elon has this like just monster server farm with, I think it's like 200,000 or so GPUs. Yeah. And that's what trains Grok, right? Like what produces Grok? Well, that does, right? It's Elon's monster training farm. But what if you had like, Templar is basically like, well, what if it was like SETI at home and we had a bunch of, random computers out there that are just coordinating to do the same thing. But Templar has an example. We know that it can happen because, that's what makes ChatGPT. That's what makes Grok, right? It can definitely happen. Whereas what you're trying to do, you don't know whether is this solvable using current techniques, or is there like some other element that we don't know about that you need in order to make generalization, possible inside of these things, right? So, what is the approach that Hone is using, and why do you think decentralizing it gives you an advantage? Like, why Bittensor, I guess?
Yes. So, so we've actually made a change. So originally when I wanted to do Hone, I have my own opinions about how I think we should do it, right? But that's why Bittensor is so, the very powerful thing about Bittensor is that through an incentive mechanism, we can have people from all across the world work on this problem and be rewarded for incrementally improving the performance on this data set, right? There is a grand prize for solving this. Not only is there's a monetary reward, but there's also a lot of bragging rights involved. But it's something where maybe my opinions are incorrect, right? Maybe someone else has a different way of going about it that might be, the actual solution. And there are very strict requirements on what can actually succeed in winning this award. So it needs to be within a compute budget. So it needs to be small and efficient, and be able to run on, I think, about $50 worth of compute. It has to be an open source model, which I think lends itself to the Bittensor network quite well, because Bittensor is an open source project that incentivizes open source intelligence, and it needs to be something that can be independently verified. So we might be able to get a really high score on, and I'll go into this a little bit later, but we might be able to get a really great score on our holdout set, but they have their own holdout set that's completely private that you actually have to score really well on as well. And so, even if you took the train set and the test set that's public on Arc and you trained on that information, it's very unlikely that you would be successful.
Right, because they don't want you cheating. That's why it's private, right? They don't want you to just like programming, just program in the answers here, the answer key. And so they want to make sure that it's a completely blind test so that the generalizations are in fact legit, not something that you've cheated and programmed in. Okay, got it.
Yes. Yeah. And so, and the way in which we've kind of modified our idea since we've been developing it, which we're actually today going to start our on mainnet, start our testing. So we're going to start out with a small incentivized run to coincide with this conversation. You can actually use any kind of architecture that you would want. So originally I wanted to just use HRMs and sort of, one moment.
Yeah. What's an HRM? Sorry, what is an HRM?
I wanted to use a hierarchical reasoning model. So JEPA is a hierarchical JEPA. So it's a bunch of JEPAs together, and then each layer of this network is predicting at different time steps. So it's like, let's say my objective is I want to get from where I am right now to the grocery store, right? So I want to minimize the cost to getting to the grocery store, but I want to maximize the immediate next step of me getting to the grocery store. And so then having each step along the way be predicted at different like timestamps. So it's like this layer might be at like a base layer of like 50 milliseconds. So from now all the way to where I'm going to be at the grocery store, it predicts in 50 millisecond chunks. And then the next layer is like 100 milliseconds, then 200 milliseconds, 400 milliseconds. That's a hierarchical JEPA. A hierarchical reasoning model works in kind of the same way. It's different though. It does use transformers. But those are both examples of novel architectures that are different than the traditional LLMs that ChatGPT and Anthropic and like what Templar is doing, that are training on. And so what I realized is that with Bittensor is that you never want to apply your own opinions on things like this. Like you want to be able to open up the architecture so that any kind of architecture can be tested. And the miners will figure that all out on their own. Like they're not going to give you a model that won't work with your test set, right? And so for us, one of the really hard things that we had to do was, okay, well, we can't spam the Arc Foundation with a bunch of these examples every hour, right? Like it's gonna be expensive for them. So what we decided to do is to be able to create our own private holdout set that we can rapidly iterate on, and then based off each incremental improvement that is given by a miner, then we incentivize and reward that, so that then we can kind of like what we've seen with Ridges and like we've seen with these other projects, be able to solve this. Now, the Arc AGI 2 competition is ending in a month, so we need to kind of get going, because Arc AGI 3 has already been released and that will be next year's competition, but we really need to get it started.
Sorry, question about 2. Is it just whoever scored, like everyone's scoring around 5% right now, but if somebody scores 6%, they win, or just nobody won?
Has to be above.
Okay, so basically nobody's going to win this year. Yeah. Okay.
Yeah. Well, not if we don't have.
You're going to go. We got a month left, so maybe you'll crack it. So kind of a tall order.
Yeah.
Yeah.
Well, and that's what's kind of very cool about Bittensor is that I actually think that it could happen because these miners will work.
Yeah, I've seen that.
For you. I mean, they're it's incredible, and it's permissionless, and so anyone can join. And I've actually known some people who've worked at DeepMind. There's some guys I went to high school with. One of them worked at DeepMind now. And I told him about Bittensor, and so when he was working at night, he'd work at night.
That is so crazy. I've heard this so many times where people are working at these big AI companies, and they're probably working their asses off, right? Like this is like not for the faint of heart. Like they're busting their ass with their work, and then they go home and they bust their ass again to mine Bittensor subnets. Like I don't know when these people sleep, right? Like it's crazy.
No, Yeah, and that's the power of this, open source decentralized intelligence collective that we call Bittensor, right? It really demonstrates that it works. And we've seen a lot of really successful cases of this happening before, like the one I gave, but also, I know like when there was Subnet 18 was doing the OpenAI stuff, there were a lot of OpenAI people working on that. And so, it's something where maybe we'll be able to pull it out. No promises, obviously, but the miners have done crazier things before.
Okay.
I suppose.
All right, so you got a month left on the clock, and so this hierarchical architecture, and I did read up a little bit on you guys. My own background, kind of schlumpy AI wise, but in the 80s. When I was in college, so I'm a little older than you, I did take an AI class, which is sort of hilarious to look back on now because it was so different from what ended up working was not at all what they expected to work back then, right? So I was learning Lisp, right, like the language Lisp, lots of idiotic, silly parentheses, as some of us called it, but it was this sort of recursive, really hard to sort of visually understand language, and then there was Prolog. There are a number of these languages, and a lot of them focused on very brittle hierarchical reasoning, right? So it was very much like, okay, so there's the category of fruits. Within this category, there are pears and there are apples and there are, and then there are vegetables and, the apples are not in this other category, right? But then they got mixed up because it's sort of like, what if you had things that were in both categories, right? It was sort of a vegetable, but also sort of a fruit, right? So they could never quite get all this stuff to kind of work right together. And it turned out sort of the more loosely organized LLM stuff, which had sloppier data, which I guess is more like the human mind, right? The human mind doesn't have like a computer hierarchy inside of it. It's very sort of loose associations between things, right? That ended up being what worked better. But now this approach that you've been describing reminds me again of sort of what I encountered in the 80s with Lisp and Prolog, the hierarchical nature of it, like reimposing. It's funny to me that actually is now sort of, it's making a comeback, right? Like, but it sort of is, right? And I guess in some ways that is what is imposing that sort of order is what is expected to lead to better generalization, right? So it's kind of wild to me. Have you ever encountered go ahead. You have thoughts on this?
Yes. So this is actually why, one of the experiments that I'm doing in my free time is I'm almost trying to simulate it where, you're probably familiar with the thinking models that have come out, like DeepSeek R1, O1, these types of models, right? So something I've been working on is batch parallel inference, where it's context aware between. So I don't know. I know this is kind of maybe going to date me a little bit, but do you remember like the little channel flipper, like, you know, like Dish TV or Direct TV, where you could like flip between these different channels and stuff. So my idea was like, well, what if the LLM was outputting like different channels, right? And each channel is like a different rung of the reasoning, right? But it's context aware, so that each layer or each channel, like what channel 4 and channel 1 are doing, it's aware of what each one is doing. This is kind of similar to hierarchical reasoning models and JEPA. Like it's kind of similar to this, but you could do it with LLMs, right? And so but the nice thing about LLMs is that it's quite discrete in what you train on it, right? Because the data that you're fine tuning with, right? It's going to do that thing really well once you really hone in on it.
Oh, yes.
See what I did there? No pun intended. So like channel 1 would be like the high reasoning, right? Where it's like thinking kind of overarching and kind of planning things out, right? And then like the fourth channel is like really thinking each step through. And so that's a perfect example of like, you know, using the techniques that we have that we know that are successful today, and just applying that to this same sort of logic to it. Now, I think it's really important not to like pigeonhole these sorts of ideas to where it's like, yeah, like this is going to be an apple, that's going to be an orange. And, you know, like it needs to be able to learn on everything on its own, or it can't be like handcrafted in that way. It needs to be able to learn it. And so those types of methods where it's like really handcrafted and really pigeonholed, unless you're doing something very specific, like which like fine tuning LLMs is like something that, you're doing something very specific. Like I'm trying to make a customer success chatbot, right? So like, I don't want it to be able to go off and talk about philosophy, right? I wanted to talk about helping the customer with these specific things, right? And aligning that and keeping it on track is actually proven something to be quite difficult with LLMs, because everything is learned. And so I agree that like, that those sort of, I think it was like symbolic learning, I think is what they called it, back in the 80s. These sorts of things have like can kind of creep back in, but it's not necessarily what we're trying to do. Because what we're like, and this was actually why with our verification mechanism, we were like, okay, like they can do whatever they want as long as they answer correctly. Right. And it'll be very hard for them to cheat because we have all these augmentations that we do on our end. So like we'll have our own private holdout set. And then once we have a model that's like really, really good, then we're going to submit that to Arc Foundation. So, and see if we can independently. So a lot of the work that we've been doing over the past couple of weeks has been making sure that we get the same results that the Arc Foundation has on the publicly available models like O1 and these sorts of things. So now we've gotten to a point where we get the same results on our private holdout set that the Arc Foundation.
All right, I want to shift gears a little bit now. So a lot of the subnets that I've been sort of digging into recently, like Ridges. Ridges, I know what their business model is. In fact, I don't even know what their pricing is, right? As of the last revenue search that they were on, I guess it was last Friday. But looking at what you guys are doing with Hone and actually Templar, like there are a couple of subnets like this. I don't know what the business is. The business, basically the subnet seems to be sort of like PBS, right? Where it's like the emissions coming out of TAO are kind of supporting the miners. Like, why do you mine the subnet? Well, because you want to get alpha emissions that are kicked off by the Bittensor subnet, and hopefully you'll hold on to those. And if this sort of research project succeeds in 2 to 3 years or however long it's projected to take, then you will, theoretically have some ownership in a future business. And we don't know what that is. I guess your future business is AGI as a service at some point, but we don't really know when. And hopefully your miners hang on to your alpha tokens. I guess my question is this: is there a business in your immediate future, or is it just mine and hold on to it and hopefully one day this will all work out? How do you think about that?
Yeah. So in the immediate future, there are prizes for this. So the prize is 750K.
And so how does that translate it for, what does that mean for alpha holders, I guess?
Yeah, so we would take that 750K and buy the alpha. Now that's like, obviously if we solve that, we've done something much bigger than 750K, right? Those techniques will be really easy to monetize because then you can translate that to production or productivity, right? So like, for example, we can integrate that into a bunch of different things, whether that's being inferenced on Targon or whatnot, right? And then, paying that back through there. But we also want to, like, something we've been talking about is using subnets. Like, we're probably not going to use subnets on Targon, or we're still thinking through it, I guess. Like, we're not here to talk about Targon.
We'll talk about your backing in a second, but please continue. Yes. Targon's one of the backers.
Yeah. But, yes, exactly. And for us, I would say a large part of the monetization strategy there is monetizing it through Targon, and through Sybil. So, by the way, our novelty search tomorrow will kind of elaborate on that more. But using subnets not just to do these sorts of competitions on actually like evaluating how these models are doing, but then creating base models through another section of the subnet, like a decentralized pre-training, or something along those lines, so that then we can, we pre-train this model, right? Then we have an evaluation framework. Now that we actually have a really great way of grounding and evaluating whether this is a great model or not. This is something I worry about with some of these decentralized pre-training ideas. There's a lot of them right now. I mean, I was just in Singapore. That's actually my background.
Yeah, agreed.
Singapore,
I've been.
It's
city, awesome.
By the way,
yes.
Not trying to get distracted, but amazing. And I was talking about this. Are you familiar with George Hotz? So George Hotz is like one of my heroes growing up. He was the first person to do a hardware unlock of the iPhone. So I don't know if you remember, but the iPhone originally was like, you can only get it on AT&T. And so he made it to work with T-Mobile, and that was, really cool. Then he jailbroke the PlayStation, so that then you could run like Linux on the PlayStation, which is really cool. Then Sony sued him for that. Then he made the original version of Autopilot for Elon. And then him and Elon beefed. I don't know what happened there, but they got into like a little beef, I guess. Got in a little fight, and he started this thing called OpenPilot, which is a dash cam that you can get completely open source software. It's a phone that you install into your car. It supports over 200 cars. You can plug it into your car, and then it drives your car for you.
He's basically jailbroken like auto driving in cars. Interesting.
Exactly. And so in this analogy, right, Tesla, I have a Tesla. I love FSD. I tell everyone it's like I rarely drive. I very rarely drive. And if Texas, it's a very large place. I drive up to see my parents. They live like 3 hours away from me. I very rarely drive. I mean, I just press a button. I bring my iPad. Or maybe I shouldn't say this publicly, but I bring my iPad. I put these sunglasses on, and it's all because once you have the sunglasses on, this is maybe helpful for other people with Teslas. You put the sunglasses on, and they have a little camera that's watching you, like your driver monitoring. So I just sit like this with really great posture, and then I have the sunglasses on, and then I watch like the football game or something like that right there. With my iPad, and I'll just sit like that. It'll go for hours. Sometimes I fall asleep. I know it's not good. You're not supposed to do that, but I mean, I've never died yet, so we'll see. But we can say that type of technology, like the FSD, is like the ChatGPT, the Anthropic, the closed source solution, right? And that does. I mean, the data collection there is incredible. Like the car is always sending back information to the mothership, and then they're training on that data, then creating a new version of the model and sending it back down to the car, then collecting new information and so on and so forth, right? And OpenPilot incorporates this same type of technology, but because they have not as great data, because Tesla has 6 cameras, maybe the and only a few cars, and it's super rigid, and they know exactly what car is running on what and all of this. Whereas like with OpenPilot, they're using 200 cars and the cameras are in different places and there's not as many cameras on, so between the FSD and these sorts and OpenPilot, right? The FSD is winning, right? And so I worry about these open source decentralized pre-training solutions running into the same issue with ChatGPT because they don't have the same data coming in. They don't, you know what I'm saying? Like they could run into the same issue as like FSD and
basically
OpenPilot.
the data rich get data richer, and data is what makes this whole thing work. Like more data you have, the better you are. Yeah,
because your distribution now you're encompassing all those edge cases, right? You're seeing the very strange situations, and so it's a lot like FSD in that regard, right? So I worry about the pre-training solutions, the centralized pre-training solutions running into this issue. Yes, they've solved a really hard problem, and it's super cool. I think like it's amazing what they've done. I mean, you can at home essentially train or contribute to this entire, this decentralized pre-training run. So that is a very hard problem to solve. But will that model that's being produced ever really be better than what ChatGPT is producing with their billion users and seeing all of those different edge cases?
I do.
You see what I'm saying?
Yeah, I get it's a problem. It's basically it's a data access, or it's really a data problem, not even a computation problem. It's like who has the best data. Yeah.
Yes.
Who has the most and best data. Yeah.
Yes. And so what's a way around that is something like what we're trying to do with Hone, where if we can actually just make a model that doesn't need as much data, that can actually just generalize in a way that like a human would, then we are actually playing a very fundamental different game than
you devalue
OpenAI
the data
and Anthropic.
You don't need the data
because
you
now
can generalize based off a very small amount of data. It's like you have all these other edge cases because you can generalize. Yeah. Okay. Yep. Makes sense.
Yes. So if we can produce a model that can generalize in this way, then that's going to be a sort of step function in AI. And that's going to be a huge advantage for us. So that's kind of the strategy around or the way that we think about it when we're approaching this problem. It's not that those decentralized pre-training solutions aren't going to, I think they have incredible teams and I think they're going to be successful and they need to solve that data problem. I think they will. They're thinking about it for sure.
Yeah.
When I spoke to them in Singapore. But, we're trying to go around that entirely and just say, okay, well, how can we create this step function and then create something that's a lot more robust of a model? And then we have distribution through Targon and Sybil. And so we can then get distribution there and then monetize that and then pay back to the subnet, right? That's kind of
Got it. Yeah. So right now you're in the R&D phase effectively. So there's no business. Maybe there'll be business. Maybe there won't be. We don't know yet. But let's just assume there is. So solve
let's
it
try
first,
to solve
invent
it first,
the thing, invent the car first. Right now we don't really have a working car yet. You're like, we suspect we can make a working car, but we don't really know.
Yeah.
Right. So we don't know yet whether, so we're not selling Model Ts to anyone just yet. We're still trying to invent the combustion engine and hopefully we get there. But if we get there first, holy shit, right? We can start cranking out cars real fast. And you've already got a car factory, otherwise known as Targon, that can immediately turn around and productize this. And if you get the bragging rights, like if you have a DeepSeek moment, like everybody knows DeepSeek because of the DeepSeek moment, right? Like everyone's like, holy shit, right? So if you get a Hone moment, right, where everybody knows where Hone is like the brand name of the world's first working AGI, holy shit, right? Now all of a sudden everybody's going to want to be running Hone on, and Targon will be like, we offer Hone and we're the only ones, right? So yeah.
Yeah, in these sorts of things. Yeah, I mean, this is if we solve Arc AGI, you're going to be reading about this in like pretty much every publication because it'll be a big deal, not just in the open source community, but it'll be a big deal in the broader AI community as well. Because no one solved it yet, right? Not even the big, AI labs, right? And I actually think that we'll be able to solve it solely because of Bittensor, right? I think it would be very hard and a lot more dollars. Like if you're Sam Altman, right? What do they asked him this question the other day where it's like, would you rather have AGI or would you rather have a product with 1 billion users? And he said, in like 5 years or something like that. And he said, I want the product with 1 billion users. That should kind of give you the sort of mindset that he's in, right? Obviously, they've raised a lot of money, so I get why he's thinking that way. I mean, if I was in his, I don't envy his shoes, right? You know, it's a sticky situation to be in because, I mean, you know, you look at the AMD deal, for example, right, where it's like AMD's like, please use our chips. We'll give you 10% of our company, right? And they're like, OpenAI's like, well, we don't have any money, so we can't buy your chips. So just give us stock. Right, and then maybe we'll pay you back. Sort of circle. Like, you know what I mean?
It's pretty, it's pretty weird. I agree.
Yeah. So I think that if we're really excited to be, launching this today, or our first test today. So if you're listening to this, please come join us in the Bittensor Discord and in the Subnet 5 channel and ask any questions. We're always there to help. And really start kind of proving this idea out. If we can just beat the large language models that already exist out there on this, I think that in itself is pretty impressive. But obviously, we're going for gold here. I mean, we're going for first place, as Ricky Bobby says. If you're not first, you're last. You know,
that is a fantastic movie. Lots of Highlander references in there as well, which I also love. So, great job. Okay, so let's talk a little bit about the backing because we've talked a little bit about Targon. Otherwise, I mean, basically the entity behind Targon is Manifold Labs. Manifold Labs is one of the entities behind what you're doing at Hone. But the other one is Latent Holdings, right? Which is JJ's, JJ's Bittensor company has, multi-pronged, right? It's funding and doing a lot of different things, including helping to upkeep the core Bittensor code, right? Like who's the foundation which sort of upkeeps that code? Well, it's not all latent, but it's a lot latent, right? Latent is probably contributing the most in terms of the actual Bittensor code and upgrades, right? So tell me what is sort of Latent's interest in this, and what do they hope to get out of it? Like, because they're not part of Targon, right? So what are they thinking? Do you think?
Yeah. So first, I mean, JJ and Voon are just some of the most incredible people I've ever met. Every time I speak with them, it's wonderful conversations. I've been talking to JJ about hierarchical pre-training and these sorts of concepts around JEPA since I've met him. It's like, I think I met him, in San Francisco last year. We walked around Presidio for like 3 hours and I just kind of wouldn't stop talking about this. Right. And so I was looking to acquire a subnet slot, to be able to do Hone. And I was telling JJ about it, and, he was like super supportive of it. And so we ended up working out a deal here where, we can share resources to solve this together. I think JJ is maybe one of the best equipped when it comes to open source governance and open source development. He's funded many open source projects and knows how that happens in the sort of Web 2 space. He organized the first Kubernetes convention back in 2020. That was in Presidio as well. And so he's just a wealth of knowledge and tremendous help, him and Voon, when it comes to this development. And so, like us with Targon, right? This is something that obviously Targon is a large business for us. It's doing really well right now. It's growing really fast, and we're having a great time with that. We're hiring a lot right now, and so we've been kind of very
that is your revenue producer one, and I know because I've been. And you guys just raised some money too, right? I think you announced like a $10 million raise or something like that.
Yeah.
So.
Yeah, we raised 10.5, and that's to sort of, there's a lot of people out there that in like the alpha space where or like that they're like, oh, I never want to raise, like VCs suck, all this stuff, right? They're also not Americans, which I think is something that maybe contributes to that. It's nothing against them not being American, right? But I feel very blessed to have been born American because I have access to these incredible capital markets that are here in America. And so, it's like, that's kind of an option for us. It's not really an option for everyone. And so we're able to weather that storm in a pretty meaningful way and that a lot of these other teams are kind of struggling with right now. And it's a pretty good trade when you partner with someone who, like, I feel like you're just getting a lot of value there, right? Like if you partner with the wrong people, I could see how that could go wrong, right? But with the people that we partnered with on that Series A, I mean, it's like been incredible, right? And it's really supercharged our growth to where now it's, what would have taken us probably 2 years to do, it's now going to take us 6 months, And so we've been working a lot with JJ on that front, and he's been a huge supporter of us, and I feel very blessed to have been able to meet him.
Yeah, I love JJ as well. I'm a big fan, and I'm a big fan of Voon. And for those who don't know, Voon is one of the core code maintainers of Bittensor in general, right? He's sort of like one of the main dudes.
Yeah.
Some have called him the dude, so I didn't want to quite say that because I don't want to devalue the other people, right? But yeah, he's.
Of course, yeah. JJ or Voon, when I first met him, it was in December of 2021, and he was the intern at the OTF, Open Tensor Foundation, and when I would talk to Jake about it, right? I mean, he is
Jacob
like the
Steves,
most
otherwise known as
consistent
Const, who is one of the co-founders of Bittensor. For those who don't know.
Yes, I mean, like me, when it comes to with me coding, like I'll go through these like very large sprints where I'll write like 40,000 lines of code, and then like maybe like I take like a week off or something like that, right? But Voon is very consistent and incremental in terms of his delivering his code and shipping his code, and he's been instrumental to the success of Bittensor through his core contributions to the code base.
Yeah,
and
no,
so,
we all love that. Absolutely. There's actually a number of people like that in Bittensor where they're very young people, but they're very awesome. Like, sort of, and it feels like we're meeting like young Bill Gateses or somebody like that, right? Who's just like insanely exceptional. We're just like super lucky that they're in Bittensor and not like an Open AI or something, right? So, and it,
yeah. I mean, and that's where they would have ended up probably, right? But Bittensor is such a better deal, I think, for the individual, right? It's something that you can really contribute from anywhere. You can be anyone. It doesn't matter who you are, where you come from, what your nationality is, what your creed is, right? What matters is, do you ship? Do you write? Can you write the software? It's a pure meritocracy.
And I think,
really cool.
Look, I think just the design of Bittensor. When I explain it to people, I'm like, look, it's this incentivization alignment engine, and it turns out you can just atomize companies and just present tasks with incentives. And like, there's no employees, there's no president, there's just tasks with incentives. And if you do it the best, the fastest, you win. And if you don't, you lose. You get nothing. You get nothing. Good day, sir. You get wonked out the door, right? Like that's just the way it works. It's the most ferocious form of capitalism ever invented. And it's not even capitalism. It's like a new thing. It's like incentivism, right? And only the excellent get anything.
Yeah, it's a something I've been learning a lot about the Qing dynasty. I don't know how this actually like kind of ended up happening. I saw this like montage of this movie called The Last Emperor. It won Best Picture in 1986. Aesthetically very pleasing movie. And also quite simplistic in terms of its like explanation of what actually happened. But that's very useful for someone like me, who doesn't know much about the Qing dynasty or much about the history of China, outside of what I learned in high school's AP World History class, right? And one of the things I've learned about when I was learning about the Qing dynasty is this thing called the imperial examination, where for thousands of years in China, there was a written test that people would take that would determine what role you would partake in society. And this was like, it was like kind of like a light bulb moment for me, because I was like, we know that Asians are performant test takers, but this is like, there's like actually like an epigenetic reason for this.
How long
like
was this test around for?
Over thousands of years in China.
Thousands of years?
Thousands of
Holy
years,
shit.
like thousands. I mean, and I'm still learning a lot about China, and Asia in general. Like after going to Singapore, I was so scared. I know it sounds kind of ridiculous. But I was very nervous about going to Singapore because it's really far away from home. I don't know anyone.
Have you traveled
there.
a lot, or is this like one of your first?
All these
trips?
people I did know were going. No, I didn't leave the country until I was like 23. Like, and then when I did leave the country, I went on like a Mediterranean.
Yeah, it sort of doesn't count.
Which is like, like it's like, yeah. And outside of that, I really haven't left like the New World. Like I've been to South America a little bit, like Peru, but outside of that, never really gone that way before. And after coming back, I'm so enamored with Singapore and Asia in general, because of things like this, right? Like it's just so interesting to learn about. And so, so China for thousands of years was like a kind of a pure meritocracy in this way. And Bittensor is likewise a pure meritocracy, where it's about how well you perform in terms of what you can actually execute on, how well you can execute, how well you can write code, how fast you can ship. And that's how it should be, right? Like, in medieval Europe, it was very much, and for a long time, and I mean, you could even say it's kind of still this way in large parts of America and whatnot. I mean, it's a little bit frowned upon as it should be, but like nepotism, the kids call it being a nepo baby, right? Like Bronny, like LeBron James kid, But, this is like Bittensor is a kind of a very pure meritocracy in this way. And so, it's something that I feel very blessed to have been a part of and to have found.
I feel the same way, and I got here a lot later than you did. So, but but it's still pretty early, I think, overall, right? Like I think I arrived in Bittensor's 2013,
very early.
So I missed like the 2011 days, but I did arrive, from.
Yeah, we are in the 2013 days of Bittensor.
Yeah.
I mean, we're about to have the first halvening. These things are like. You read these chats and these people, and it's just like, like you didn't want to be reading these things in 2013 about Bitcoin, right? Like all those takes were totally wrong. I remember my dad, he would tell me Bittensor's a scam, it's a Ponzi, but it was immediately practical to me because I couldn't get a bank account, and I could buy Second Life currency with Bitcoin, and then I could convert that Second Life currency into dollars in a PayPal, and then I could pay for that. I could pay for a Minecraft server that way. So that was like
so your dad didn't say Bittensor was a scam. He said Bitcoin was a scam. Yeah. Yeah.
Bitcoin was a scam.
I just want to make sure that's clear because I understand. I picked up on that.
Just to be clear. No, just to be clear, Bitcoin in 2013 when I was telling you about it, right? No, my dad does not think Bittensor is a scam.
He's figured it out by now.
Yeah. But like, you would read like, oh, Bitcoin's dead. Bitcoin's dead, and I mean, the number of times that it's been declared that Bitcoin's dead, it was over 10 years later that, it's really started to reach this sort of mainstream adoption. Imagine where like a really great example as well is like, you look at a lot of these like seed stage Series A investors in like Uber, Robinhood, these like huge successful companies, or Coinbase, right? Like they're just kind of hitting their stride now, 10 to 15 years after their inception and creation, right? Like in terms of the value creation that's happening. I mean, I'm a huge fan of those companies. And, so think of like, with Bittensor, I'm being very precise now, make sure I'm not getting that confused. But with Bittensor, I mean, I really think that it's like, we are really so early in terms of its adoption, right? And so a lot of this noise, I just ignore. And you got to focus on.
Yeah, no, I agree with you. I mean, obviously, look, we, I was around in Bitcoin 2013. I wrote some books. I wrote like my first one about Bitcoin in 2013. I wrote a second one in 2015. Right in the middle of all that, it's gonna die. It's a scam. Blah blah blah. I think though that Bittensor's rise will be faster than Bitcoin's because Bitcoin has paved the way, right? It's sort of like after the first internet company or the first mobile phone company does something, it's a lot easier for anyone who comes afterwards, right? So, we don't have to wait for the exchanges to be built, like, because Bitcoin kind of did all that missionary work for us, right? The railroads are up and running now, so we can, Bittensor, what took 10 years should now take 3 years, something like that, right? It's sort of my guess. So, yeah.
Yeah, exactly. I mean, in the 2000s, right? none of those lines even really existed. The internet lines, I mean, right? Like they had to physically go dig and put the cables in the ground, right? Whereas now, and like I was talking about with James, you know, James, my co-founder, it's like the thing of people say, oh, it's an AI bubble. We're in an AI bubble, right? I actually don't think that we're really in an AI bubble, right? Because one, this is like when I use this technology, I mean, I feel so incredibly productive. What used to take me weeks before, I can do in a few hours, and I can do it after drinking like 6 Bud Lights, you know? I mean, it's incredible, right? But also, like, we have the means of distribution are already there as well, right? Like, it's not like the internet where it's like pets.com. You know, you needed someone like Amazon to come along and actually build that whole infrastructure out. That infrastructure exists today, and it's primed for AI adoption, in my opinion.
Yeah, no, totally agree. All right, dude, we're coming up on the hour here, so I want to wrap it up. Any final thoughts? Anything you want to plug before we go?
Yeah, well, we're going to be going on Novelty Search tomorrow to talk about Hone and Targon and Manifold and where we're at. That's going to be October 9th. You know, in case
it'll come out today, so it'll be tomorrow if you're watching it on the first release day. Yeah, so 2 p.m. Pacific time tomorrow.
Yeah, and and so you know, join us there. We've done a lot of big upgrades when it comes to Targon. You can now do cluster rent, or you can rent GPUs. We're going to have cluster rentals. We have network storage. We've moved all of our consumer inference over to a new platform called Sybil. We'll be talking a lot about this tomorrow.
Yeah, I'll be there. So I'm definitely looking forward to it. So yeah, I'm a big fan of what you guys have been doing at Targon for quite a long time, as you know. Right, I've actually visited your offices. So you know.
Yeah, no, I remember. Right. Yeah, we had the VPs on the whole nine.
Hey, you guys all had. That was a surprise to me. Oh, you guys had your Vision Pros on, Apple Vision Pros, and that was like your main computing environment. I'm like, what have I walked into here? Like, I didn't expect that at all. So I thought,
No, it's so incredible. You can have like, especially in the football season right now, I can have the game going on YouTube TV, and then, like, you know, it can be coding. I don't watch it on Sundays though, because I can't afford the Sunday ticket. Okay, maybe that's something I should plug. Reduce the cost of the Sunday ticket. You know. All
right, dude. Super appreciate your time, and thank you for putting up with my questions and explaining all this to me and to the audience. My name is Mark Jeffrey. This has been Hash Rate. We'll see you all next time.